This is section 4.9 of Honors Algebra 2, solving polynomial inequalities. So we solved polynomial equations, and the way we did that was to factor one side and use the zero product property, the fact that two things multiplied together must be zero, or two things multiplied together equal to zero mean that one of them, or both of them, must be zero. Here we're going to solve polynomial inequalities. We're going to use one of these two properties. AB is greater than 0 if and only if A and B have the same sign. So if I multiply two positive numbers, like say 3 times 5, that is 15, which is positive. I took two positive numbers, multiplied them together, I got a positive number. If I take two negative numbers, negative 3 and negative 5, I still get a positive number. So if they have the same sign, then their product is positive. And that's the only way their product can be positive. If they have opposite signs, where one is positive and one is negative, then their product is always going to be negative. So if I took positive 3 times negative 5, I get negative 15, which is less than 0. If I took negative 3 times positive 5, I get negative 15, which is less than 0. So if they have the opposite signs, their product will always be negative. And that's the only way their product can be negative, is if they have the opposite signs. So we're going to use those two ideas to solve polynomial inequalities, which means we need to get 0 on one side and a product of things on the other. So we need to factor the other side. So here's how we're going to do it. I need a 0 on one side, so I need everything else on the other side. So I'm going to add x squared to the left-hand side. And I'm going to subtract 4 over to the left-hand side. So I get x squared plus 3x minus 4 is less than 0. Alright, I have a 0 on one side now, so I need to factor the other side. So I can factor x squared plus 3x minus 4, and it's going to be x plus 4 and x minus 1. So x plus 4 times x minus 1 is less than 0. Their product is negative. That means one of them is positive and one of them is negative. So let's suppose the first one is positive. Let's say x plus 4 is greater than 0, and x minus 1 is less than 0. That's one possibility, in which case x would be greater than negative 4, and x would be less than 1, which is the same as this compound inequality. Since there's an and, it becomes this compound inequality where x is between negative 4 and 1. The other possibility is for x plus 4 to be negative and x minus 1 to be positive, in which case x would be less than negative 4 and x would be greater than 1. But that's not possible. X can't be less than negative 4 and be greater than 1. So this side needs to know solution. But we still have solutions because of the first option, where x plus 4 was greater than 0 and x minus 1 was less than 0. So our solution set is set of all x such that negative 4 is less than x, which is less than 1. And then we would graph it. Negative 4, negative 3, negative 2, negative 1, 0, 1. And x is going to be between negative 4 and 1, but not include negative 4 or 1. So we graph these just like we've graphed inequalities before. Number 2. This one's already factored. X minus 4 times x plus 2 is greater than 0. So let me show you a different method of doing this rather than having to run through the two options. If we just take the two zeros of the function, so in this case x of 4 and x of negative 2, and let's graph those. Negative 2, negative 1, 0, 1, 2, 3, 4. Then those are going to be the defining points of our inequality, just like negative 4 and positive 1 were in the inequality on the left. So what we can do is pick numbers in each of the three sections that have now been defined on our graph. So we put an open circle at negative 2 and 4, because I can't include those. We want it to be greater than 0, and that's where it equals 0. But those are the boundaries, in a sense, of three different sections of my number line. And all I have to do is check one number in each of those three sections, and see whether or not it makes the inequality work. So if I pick negative 3, and I plug in negative 3 for x, I'll have negative 3 minus 4 times negative 3 plus 2. Negative 3 minus 4 is negative 7. Negative 3 plus 2 is negative 1. And negative 7 times negative 1 is positive 7, which is greater than 0. And that's good. I wanted it to be positive. So anything to the left of negative 2 is going to lead to a positive number. In the middle, let's say I plugged in 0. That's between negative 2 and 4. So 0 minus 4 times 0 plus 2 will be negative 4 times 2, which is negative 8, which is less than 0. So that's negative in the middle. And to the right, if I picked 5, 5 minus 4 times 5 plus 2 is going to be 1 times 7, which is greater than 0. So I've now figured out what happens in each of the 3 sections of my number line. I'm positive anywhere to the left of negative 2. I'm also positive anywhere to the right of 5. And I want to be positive. So those are the sections of my graph that I need. I'm negative in between negative 2 and 4, but I don't want where it's negative. I want only where it's positive. So I'm going to shade everything to the left of negative 2 and everything to the right of 4. And that's my graph. So that's another way you can do it, is to find the zeros, find where it equals 0, put those on your number line, and those will define off or cordon off sections of your number line. And just pick a number in each of those sections and check it. So I'll show you how to do that again here. 9x is less than or equal to x cubed. Let's get everything on one side. So maybe I'll move everything to the right. So 0 is less than or equal to x cubed minus 9x. Now we have a 0 on one side, so we need to factor the other side and look for a greatest common factor. And they each have a factor of x, so we can take that out. And that will leave us with x squared minus 9. X squared minus 9 is the difference of squares, so that's x minus 3 times x plus 3. And now I have it factored. But now I have 3 things. This equals 0 if x equals 0, it equals 0 if x equals 3, and it equals 0 if x equals negative 3. So those are the numbers I'm going to start with on my number line. And here I'll put a dot at each one because I'm allowed to equal 0. We have 0 less than or equal to x times x minus 3 times x plus 3. So I'm allowed to equal 0. So I will actually put dots there, not open circles. Then I'm going to pick a number in each of those 4 sections, and I'll check it. So if we pick negative 4, what happens at negative 4? And I can either plug this into my original function, my original inequality, or my factored inequality. Either way. I think it's sometimes easier to plug it into the factored one. And I have negative 4 times negative 4 minus 3 is negative 7, and negative 4 plus 3 is negative 1. And all I'm really interested in is not the number, but the sign. Is it positive or negative? And this is going to be negative, because I've got a negative times a negative, which would be positive, times another negative is a negative. So this is going to be less than 0. So it's negative to the left of negative 3. So I put a negative in that section of my number line. I'll pick a number between negative 3 and 0. How about negative 1? So at negative 1, is it going to be positive or negative? So I've got negative 1 times negative 1 minus 3 is negative 4, times negative 1 plus 3, which is positive 2. So this is going to be positive. Negative times a negative makes a positive, times another positive is a positive. I'll pick a number between 0 and 3. How about 1? That will give me 1 times negative 2 times 4, which is negative. So everything between 0 and 3 would make this inequality not work, because I want it to be positive. And I pick a number to the right of 3. How about 4? That would be 4 times 4 minus 3, which is 1, times 4 plus 3, which is 7, and that's going to be positive. So everything to the right of 3 will end up positive. So I want only the places on my number line where this is greater than or equal to 0, or where 0 is less than or equal to it. So I want only the places where it's positive. So that's between 3 and 0, and greater than 3. And now I can write my solution set, which I guess I forgot to do on number 2. I'll go back and do that in a second. My solution set here would be the set of all x such that x is between negative 3 and 0, including both negative 3 and 0. So negative 3 is less than or equal to x, less than or equal to 0. or x is greater than or equal to 3. And I have to include the or because I'm indicating that I will take anything in either one of those regions. So that's my solution set. Now let me go back and put the solution set in number 2. I forgot to do that. So my solution set here ends up being the set of all x such that x is less than negative 2 or x is greater than 4. Example number 4. Y minus 1 times y plus 1 is less than y plus 1. I don't have a 0 on one side, so I need to get a 0 on one side. So let's move those things over to the left side, subtract y and subtract 1, and now I have it all less than 0. But now my left side is not factored anymore, because now I'm doing some subtraction over there. So I actually need to FOIL out y minus 1 times y plus 1, combine like terms, and then refactor. Let's do that. Y minus 1 times y plus 1 is a difference of squares. It's going to end up as y squared minus 1. And I've got a minus y minus 1. So combining like terms, I get y squared minus 1 minus 2. Y squared minus y minus 2. And that is less than 0. Now I refactor the left-hand side. Y, negative 2, positive 1. Y minus 2 times y plus 1. So I'm going to look at what happens at negative 1 and at 2. Or we're going to plot those and look what happens around them. So what happens to the left of negative 1? Say at negative 2. Negative 2 minus 2 is negative 4. Negative 2 plus 1 is negative 1. So that's going to end up positive. A negative times a negative. So that is positive over there. In between negative 1 and 2, say at 0, I will have negative 2 times 1, which is negative. So everything between negative 1 and 2 is negative. Everything to the right of 2, say at 3, will be 3 minus 2 is 1. 3 plus 1 is 4, and that will end up positive. So I'm only interested in where it is negative, where it is less than 0. I'm only interested in this section in the middle. So my solution set of all x such that x is between negative 1 and 2. Negative 1 is less than x, which is less than 2. It's just less than because we're not allowing it to be equal to 0 here. Last example. X to the 4th plus 9 is less than or equal to 10x squared. Bring everything to one side, so x to the 4th minus 10x squared plus 9 is less than or equal to 0. Factor the left-hand side. And you've seen how to factor things like this, where you have a x to the 4th term and an x squared term, but no x cubed and no x. It just factors like normal, except instead of x and x, we have x squared and x squared. So factors of 9 that add together to give us negative 10, about negative 9 and negative 1. Alright, we have x squared minus 9 times x squared minus 1. We're not done factoring, because those are each difference of squares. So x squared minus 9 factors as x minus 3 times x plus 3. X squared minus 1 factors as x minus 1 times x plus 1. And now I'm done factoring. And now I've got 4 numbers that I need to graph. This will be 3, that's negative 3, that gives me 1, and that gives me negative 1. So I'll have negative 3, negative 1, 1, and 3. I will put a dot at each one because I'm allowing it to be equal to 0, and those are the places where it's going to be equal to 0. I will pick a number in each of those 5 sections of my graph. I will check them and see whether it's positive or negative at those places. So at negative 4, if x equals negative 4, am I positive or negative? Well, x minus 3, if x is negative 4, is going to make that negative 7, and then negative 1, and then negative 5, and then negative 3. That's 4 negatives, which will end up being positive. At negative 2, which is between negative 3 and negative 1, we'll have negative 5, positive 1, negative 3, and negative 1. So that's 3 negatives, which will make this negative. At 0, which is between negative 1 and 1, we'll have negative 3 times negative 1 times 1. Those are 2 positives and 2 negatives, which will all become positive then. So positive in between negative 1 and 1. At 2, which is between 1 and 3, we'll have negative 1 times 5 times 1 times 3. That's 3 positives and 1 negative, which keeps it negative. And then at 4, which is to the right of 3, we'll have 1 times 7 times 3 times 5, which is all positive, so their product is positive. Now I'm only interested in where it is less than or equal to 0. So I'm only interested in the places where it's negative, so between negative 3 and negative 1, and between 1 and 3. So my solution set is a set of all x, such that x is between negative 3 and negative 1, including negative 3 and negative 1. So negative 3 is less than or equal to x, which is less than or equal to 1, negative 1. Or I'll take anything in the other region, between 1 and 3. That's my solution set. Take anything in either one of those two regions. Here are your two immediate practice problems. Solve and graph the solution set. X squared minus 5x plus 6 is greater than 0. And number 2, 4x squared minus 16 is less than or equal to 0. That is the end of section 4.9.